Welcome to this session of the National Middle Level Science Teachers Association's Meet Me in the Middle virtual share-a-thon. As with our face-to-face share-a-thons, each presenter has prepared a short presentation for the attendees. Unlike our face-to-face event, the presentations have been pre-recorded and stitched together. The presenters will be available to answer your questions or for further explanation after all the presentations have been shown. On behalf of NMLSTA, I would like to thank all of our presenters. Now, on with the share-a-thon.
The 3 C's of bridging the gap to scientific literacy. Hello, middle school educators. I am Jennifer Ledbetter. I teach 6th grade ELA and social studies.
And I'm Lisa Reese. I teach 6th grade math and science. We are here today to share our thoughts on the importance of science literacy in middle school. We are both experienced middle school educators who have a strong belief that our students learn best via connected content throughout their day.
Sagan's words resonate in education because the future our students face is one that is centered around these 2 topics, science and technology. As teachers, we are directed to recruit future scientists, inspire students to join STEM career fields. However, we propose that a more vital directive should be to create an environment of science-literate learners.
What is science literacy? According to the NSTA, Science and Children, science literacy is knowing how to use science to make decisions. Science-literate learners translate into scientific thinkers, problem solvers who know how to seek and use evidence, and express their understanding in a way that is clear to others.
In middle school, the content difficulty increases, and students can feel that they are drowning in complex information. Comprehending and analyzing text require the use of literacy strategies. This is where the science teacher often feels like they are the ones drowning. They have not been trained or have the experience teaching students to read or write effectively. ELA teachers and librarians have that training. Use your peers to help navigate the way to success. According to an article by Christina Hopkins, reading science integration is needed for students to truly develop as scientifically literate citizens. Literacy in the science classroom is necessary to engage students as lifelong science learners.
The NSTA position calls for using evidence to create and support arguments and to engage in discourse. If teachers are going to teach science and literacy together effectively, teachers need support in the form of time and training. We need to get on board together and head in the same direction in order to build meaningful experiences for students.
That final destination we all seek is, of course, science literacy. We can reach it by using the 3 C's of science literacy, collaborating with colleagues, using consistent tools, and making visible connections across the curriculum. We are going to explain how to build a bridge that allows students to reach the state of being science literate.
Collaboration is key to effective teaching. This means partnering with others in your grade band, working with curriculum coaches, or other professionals in the field. Research shows that collaboration among colleagues builds more effective schools. To build science literacy, collaboration between science and language arts teachers, as well as content curriculum coaches, needs to happen on a regular basis. Collaboration goes hand in hand with consistency. When you order your drink at different Starbucks locations, you know that your drink is always going to taste the same. By consistency, we mean using similar vocabulary and processes across disciplines. For example, using the race reading response strategy in science as well as ELA will increase student success in developing strong scientific literacy.
Here is the race reading response strategy that Lisa mentioned. It stresses using evidence to support a claim. There are also higher-order thinking question stems and nonfiction conversation starters. The key is that the same terms and expectations are consistent within both content areas.
Jennifer and I collaborated on having our students write a research paper in science class, using research skills they were learning in language arts to deepen content knowledge and improve their writing. By partnering together, I was able to use the same terminology and graphic organizers they were already familiar with in language arts, and the project was a success. The 3rd C, connections across the curriculum, are easily implemented with project-based learning. We have a water unit that is cross-curricular. While reading the novel A Long Walk to Water in ELA, students focus on human impact on the water cycle in science and ancient river civilizations in social studies. The culminating project involves the design and presentation of a water filtration device to stakeholders and a fundraising walkathon.
Through this PBL and others, students have been able to decode informational and fictional reading of complex text, find evidence to support opinions, present their findings to the class, etc. These tasks are all part of the NGSS three-dimensional learning model as well as the ELA standards. Keeping the same strategies, vocabulary, and processes will provide a richer learning experience. Science literacy is important because it provides a context for addressing society's problems, and because a science-literate populace can better cope with many of its problems and make intelligent and informed decisions that will affect the quality of their lives and those of their future children. We invite you to scan the QR code to see our site on science literacy. We've listed our resources for this presentation, as well as sites and materials that we think will be helpful. We thank you for joining us on this journey as we bridge the gap to science-literate learners.
Hi, Liz Martinez here. So excited that you're joining me today for Stack the Deck at the Meet Me in the Middle Day, sponsored by the National Middle Level Science Teachers Association. So welcome once again. We're going to take a look at 3 different activities dealing with the shipping industry, which is so critical to our economy. So if we take a look around us, our students take a look around them, so many things are imported into this country. Exportation of U.S. goods, too, is an extremely important part of our economy. So it's very good for them to start taking a look at the idea of exports and imports and thinking about where do these items go, where do they come from, and how do they get from point A to point B. So in this case, we're taking a look at the shipping industry, and we're going to take a look at the first part at 2 different websites so that they can take some time looking through some interesting databases. This is on the 17th of March, and the next one will be from the 18th of March. Both are from 2 different websites that are fantastic, lots of information. And the students can hone in on those different spots there, those different icons, each one of them a different vessel. And they can learn a whole lot more about those vessels. And that's part of what we want them to explore is what type of vessels are used on the ocean? What type of vessels are used for shipping? What countries do these vessels work for? What is on these different ships? So on the marine traffic one, the previous one that you saw, if you go under to the heart there to the layer icon, you click on that. This is very intuitive and easy for the students to use. So it will pull up then all those different types of crafts that they represent on their website there. And the students can pick several to go ahead and take a look at. They can take a look at the ports of call. They can take a look at where these are on their journey. They can oftentimes find out what might be in those containers. Sometimes the very specifics of it are pretty tough to find, but they're able to find some information about it. They can go ahead and start collecting a fleet, if you will, a set of ships that they want to follow. So now that they've had a chance to explore that there are these different types of vessels that bring goods back and forth, we have a problem to set forth to them. We have these products that we want to export. We put them in these steel containers, these shipping containers. How do we then load these onto the ship so that they arrive at their next destination intact? So we're going to do a little simulation here. There's a template for them to make the shipping containers. They go ahead and cut them out, they assemble them, and they fill them with different things from around the house or the classroom if you're back in face-to-face there. So with the things that they want to fill them with, you'll see in the next slide what I filled mine with. I just went around the house and gathered some things. I tried to find some things that would roll, some things that wouldn't roll very easily, some things that were perhaps more fragile than other things. Lightweight, heavyweight, odd shapes. Also too, in case the rice container broke open, I went ahead and made sure that I put that in a plastic baggie. I just wasn't into picking up all that rice. It was also nice to know what was the heaviest to the lightest. So now that I had them packed, I need to have a platform to ship them on. And I need an ocean. The ocean is simulated by a plastic baggie blown up. And then you can see that the cardboard right there represents the boat platform. So now my team needs to go ahead and take a look at how are we strategically going to place those containers on the platform, and then we can rock them back and forth side to side to represent the ocean, whether it's a smooth sailing time or maybe there's a rough event going on, because our goal is not these 2 pictures right here. We want our materials to arrive safely. So after trying some lighter weather, some more difficult weather, and if we test them and we see that they're doing well or they're failing, we can go ahead and do that engineering design cycle, and we can do our reiteration based on the data that we found in our new plans. This is just a little bit of information about some of these shipping containers because there are a whole lot of them that are empty. And just as a little extra tidbit, right now there is a worldwide shortage of those containers, which has impacted, obviously, consumers receiving their goods on time. So now McLean's name is on there because he is the one who invented these shipping containers. So our students now are the engineers and they've been hired, and their client wants a shipping container to be reimagined or repurposed, reused. So we have them make scale drawings to show both the exterior and the interior details of whatever they are going to reuse this shipping container for. There's an example of a marvelous house that you can find, and there are lots of other examples, plenty of them online for them to take a peek at. So once again, this is Stack the Deck, Liz Martinez. Please contact me with any questions. I have templates, etc. Whatever you need, please contact me. Thanks again for attending.
Hello, my name is Stacy Thibodeau. I teach in Lafayette, Louisiana. I teach chemistry. And I just wanted to share with you a little bit today about how I use science simulations and digital notebooks in my high school chemistry classroom. This is applicable to any content area of science and or high school, middle school, elementary school. But again, I just wanted to share a few things with you guys. So why use simulations? The big thing about using simulations is it's challenging for students. It gives them experiences that they might not get in the classroom. And they're also able to demonstrate abstract concepts that maybe we weren't able to get done in before. So I have 4 different websites or organizations that I use for simulations. So check them out. Why digital notebooks? Well, lots of studies have found that students really need to take notes in old school format of actually writing. This helps with you as the teacher to scaffold your notes, possibly give digital study guides. They always have the information to go back and forth to. Can be a learning log, permanent record of their learning. The 2 digital notebook platforms that I use are Google Slides and ClassKick, and I'm going to show you an example of my ClassKick today. All right, so this is a simulation that I use in high school, but there's also one for middle school, and it's called Build an Atom. It covers the atomic structure in GSS standard MSPS 1-1. And so basically what students are going to do is add the subatomic particles, protons, neutrons, and electrons to the atom, and then watch where they go. So the first step, they would add a proton, and it's colored red. And we notice it goes in the center. Then there's some information over to the right that talks about a plus ion. And then on the right, left-hand side, the name pops up. There's a little scale with a 1 for a mass, and then some numbers are popping up all over. If we click on the next one, which is a neutron, it adds it also to the nucleus. The charge did not change. The mass does. And so we're starting to have some conversations about what is actually going on. If I add the third subatomic particle, an electron, we notice it does not go in the nucleus. It is now a neutral atom, and the mass did not change, and some of those numbers up there in the left-hand corner did not change either. And if you add one more neutron, it makes it unstable. And so what does that mean in terms of what's happening with the atom itself? And so I have a conversation with students about things that they've learned from this, and then we write everything down in our digital notebook. And so this is actually a picture of what I use in ClassKick, and we document what we learned together. We talk about the proton. Where did we find it? It was in the nucleus. What about the neutron? And so on. And then we add things like adds to the mass because we saw the mass increase. Is a positive charge? Is a negative charge? We had something with stability. We had something with making -1 and +2 ions. So this was how we would document our learning. Another part of the activity that I really like is now as a challenge. And the challenge is students get to take their knowledge, what they just learned, and apply it into actual elements. And so there's a difficulty level, again, depending on where your students are and also grade level. And then they press start. And so here is our atomic symbol with some numbers. What does that 8 mean? Oh, hopefully they remember that the 8 was red. And the protons were red, so they can click up and add 8 protons. They should have learned also that mass is protons plus neutrons, so they can add the neutrons. Electrons, here's a teachable moment about charges. This one is also oxygen, but the top left number is different. And so why is it different? Because it's different neutrons, and then you can have a discussion about isotopes. If you're looking for an assessment piece, it can be built into this as well. And so these are just like clicker questions that were in the actual simulation activity. I created these. You could have them in any format, but it makes it nice that it's all in one neat little space that the students can either use on their calculator, or if you're in a digital virtual classroom, then the student teacher could project, kind of like I'm projecting today. So hopefully this was what you were kind of looking for with simulations and digital notebooks. Please feel free to reach out to me. I know I said I teach high school, but I really enjoy working with teachers all over. I get ideas, they get ideas, and it's just a great time to be teaching and learning from each other. Thank you.
Hello and welcome to Meet Me in the Middle at NSTA. My name's Dave Curry. I'm a middle school science teacher in Newtown, Bucks County, Pennsylvania. Be sure to check the title slide at the end where you'll have a link to the full set of activity guides. The reason I'm giving this presentation is I was a summer participant in Project Atmosphere, an intensive 1 week, actually 2 week graduate course on meteorology through the American Meteorological Society. It's almost free to K-12 teachers. If you don't know anything about the American Meteorological Society, it's a great resource for teachers of science, and you are able to take reduced cost graduate courses that will give you background in many different subjects, namely the atmosphere, weather. You can also get a background on oceanography through DataStream Ocean. By the way, DataStream are the name of the courses. And finally, they offer a course in climate science, which is really outstanding. It's called DataStream Earth's Climate System. I've taken all those courses, by the way. So this is a FEMA map of the areas of Texas that were under emergency declaration. And you can see it's most of the state, all of the state actually. But why was that? It all has to do with the jet stream. So the jet stream has everything to do with what happened to Texas during the February of 2021. And I'm sure they're going to be talking about it for a long time, but understanding the jet stream is important for students and teachers. So let's dive right in. This is a station model of that is used by meteorologists. It basically gives surface conditions, but I want you to look especially at the wind, which is shown at about the 11 o'clock spot. It's a line with two lines sticking out from it. I want you to think of that as like an arrow hitting an apple. So the arrow is the line, and the feathers on the arrow would be the lines coming out. The more lines you see, the more feathers, the faster the wind. If you see a triangle, that means it's 50 knots. If you see a single line, that's 10 knots for every one of those, and a short line is 5 knots. So this activity, which is outstanding for high school students, but I would really do it as a teacher so that you have an understanding of the jet stream and then figure out how you want to tailor it for your students based on their ability. We start out with an image of upper level winds. These are winds above 30,000 feet, anywhere between 30,000 and 43,000 feet, which we call the 300 millibar level. And you can see that the winds are pretty fast up at that level. So let's circle all of the winds that are 60 knots or greater with a pencil. Blue pencil is nice because it stands out real well. So any wind measurement at this level that has a triangle plus one 10-knot line will circle, and we get this. If you then shade in the top boundary of that, and when I say top boundary, I mean the northern boundary of that and the southern boundary of that, and then shade that in, you can see that you have a very wavy pattern. This is the jet stream for the United States at this time, and the blue line is the specific jet stream. So here's a different map. You can see that the winds are still fast, but the overall pattern when you shade them in looks a little different. So when you shade in the 60 knot winds and higher, you get a pattern that looks like this. And then if you shade in the top boundary or the northern boundary and the southern boundary, you get a different pattern. This is a less wavy, but more kind of straight pattern. And when we look at what this gives us, the second drawing we drew was more like the one on the left, where the winds are pretty much from east to west, and the one on the right is what happened with Texas. You had cold polar air being brought down to the south, and that really affected Texas in a negative way, bringing Arctic air down to their location. So I encourage you to try this activity with your students. The link on this current slide will take you to the entire workshop handout, and thank you for your time. Have a great day.
Welcome to Telling Data Stories. I'm Lori Chen for National Middle Level Science Teachers Association. Data visualizations can be used to identify patterns across multiple scales. They can be used to spark questions from your students, to differentiate between cause and correlation, to decipher the mechanisms of cause and effect, support explanations of data, and even support explanations of phenomenon. I generally think of big data sets as those that are collected by our government agencies and scientists, and our small data sets as those collected by students. Both are using maps, graphs, charts, images, diagrams, and models for communication. And our progression through this is to first start by analyzing a big data set, telling that data set story, asking questions, designing investigations, looking at the data, visualizing it, and telling that data story. And sometimes that leads us back into big data, and sometimes it can terminate with just explaining a phenomenon or just explaining the results. An example of a phenomenon could be one that's happening here in New Jersey, where we're seeing migration of fish from warm waters to cooler waters, and we're also concerned about what's happening with shellfish as we experience ocean acidification. So since this involved temperature, the first place we began was with a model called Earth that allows students to analyze and collect data from 2014 to the present. And yes, we are seeing sea surface temperatures increasing off the coast of New Jersey. We then contacted Dr. Grace Saba from Rutgers University, who is using the Slocum gliders to study ocean acidification. She told us her data sets would have to be sent as visualizations. So we worked with those visualizations. We honed in first as a comparison of temperature and pH. Students noticed there seemed to be a relationship between the temperature and pH. And so they designed an experiment where they were asking the question, how does temperature affect the pH of saltwater? They used our vernier sensors for pH and temperature, collected data, visualized the data, and they noticed that cold water tended to be more on the acidic side or less alkaline, and that warm water tended to be more alkaline. And this was a confusion because, oh my gosh, what does this mean in terms of ocean acidification? So we went back to the big data, and the big data says, yes, we are at risk for ocean acidification. It seems to have something to do with rising carbon dioxide, rising temperatures. So we discovered argonite and began taking a look at the argonite projections and data collected by NOAA using a model. That led us then to having to understand what all of this means, and to do that we used a diagram, and that inspired some investigations using calcium carbonate in different pHs, dry ice dropped into water, and watching changes in pH as the carbon dioxide in the cylinders became equal to the carbon dioxide in the air in the room. By the time we had gone through many big data sets and small data sets, we were able to identify the cause of the problem as increasing atmospheric carbon dioxide, that our threats were rising sea surface temperatures and reduced ocean pH, that temperature could explain fish migration, that acidification could explain the threat to shellfish, and therefore we would need to be able to look at either mitigation or adaptation strategies. This is Telling Data Stories. If you have questions, please contact me.
Greetings from Mars. My name is Melissa Sleeper. I am a member of the National Middle Level Science Teachers Association Board. I am also a NASA JPL Solar System Ambassador. I am a science and STEAM teacher at Gifford Middle School in Vero Beach, Florida. Today, I am going to share with you some resources that you may use to enhance your study of Mars. Need a 1-minute explanation about various characteristics of Mars? Mars in a Minute is your answer. They are super quick videos with lots of information. Need to know the current weather on Mars? Head over to the Mars Exploration Program website. In addition to the weather, find recent images and the latest findings. You can also find information about the spacecraft, manipulate a 3-dimensional model of the rover, explore the interactive landing site, and listen to the sounds of Mars. You can also find other fun facts about some of the additional things that were incorporated on the rover. Need infographics to compare Mars to other celestial bodies? Look at the Mars Facts website. Not only can you spin the planet to explore its features, but you can find some really cool graphics to include in presentations. Need standards-based videos that include activities and lessons? The NASA Eclipse is the site for you. Want to incorporate the mission to Mars into your lessons? The Mars Student Challenge includes videos, lessons, and tasks for the students to complete for each step of the Mars 2020 mission. From planning to sampling, it's all there. Want to experience the entry, descent, and landing? This interactive allows you to control each step of the process. Getting excited about the flight of Ingenuity on Mars? Go here to watch a demonstration of the technology being deployed and then manipulate the 3D model to explore how she was built. Teaching virtually? Go to Learning Space to find lessons to use with your students. From flying a paper helicopter to coding a Mars helicopter, you will find something to use with your virtual students. Want to drive the rover around your living room? Download the free Mission to Mars AR app to get started. You can go from driving the rover to looking at the feature of Mars, all with your phone. Want to find other ways to get involved with Mars? Send your name to Mars on a future mission, or use the Mars photo booth to put yourself virtually on Mars, or go to the Image of the Week site to vote for your favorite image that was sent back by Perseverance during any given week. As you can see, there's lots of available resources to study Mars. If you need more information, please contact me. Thanks for listening.
Hello, my name is Vanessa Olson, and I am a STEM teacher at Walther Christian Academy in Melrose Park, Illinois. I am a 24-year veteran teacher, and I've taught primarily science and ELA throughout my career. Walther hired me to help build a middle school program in a high school building from the ground up. At Walther, we decided to use the NGSS standards to build our STEM program. Here you'll see the scope and sequence for our every other year cycle for both our 6th and 7th and 8th grade science classes. The first example I will share with you is our Shoot, Throw, Energize, Maneuver project. It is an Invent, Create STEM project, and the problem is to propel a ball into a goal using a device that we create. This is our Introduction to STEM project. On this slide, you'll see the template that I use each time I create a STEM project that is aligned with NGSS. In this case, you'll see both the blank and the completed template for the Shoot, Throw, Energize, Maneuver project. These are sample projects from the first year that we tried this particular STEM project, Shoot, Throw, Energize, Maneuver. Notice how we have a variety of ways to solve the problem of propelling a ball into a goal using a device students created. This is a sample Earth space science project for my STEM students. In this case, we are taking an existing design and we are going to revise it to solve the problem as stated below. The original design that my students will revise is taken from this particular link from PBS Kids. I give them this so that they can build the original design and then revise it per my specifications. Here you'll see what their revised designs look like after they revised the PBS Kids Mars rover. They were able to change a couple different aspects of their design to complete their challenge as stated in the problem. Who's That Bird is a life science project that is also a revised make project. In this slide, you'll see the problem stated that my students were challenged to complete. Here you can see samples of both their project worksheet and the rubric that I used for this particular project. I like to use graphic organizers such as these to help my students organize their thinking and their planning for the project. Here you see samples of 2 cards that give specific characteristics that the bird must have. You'll also see a picture of a project that my students did that will conform to these particular specifications. Here is a sample physical science project, and that our polymer project that is also a revised make. Students use basic slime as their base recipe and will then be making modifications per the specifications listed here in their problem. This slide shows a couple students demonstrating the flexibility and the stretch of their polymer. Believe it or not, this particular polymer stretched around the room, very thin, but never actually broke. This is the graphic organizer I use at the end of each STEM project that has students go back and reflect on how their project was STEM. We lay out the specifics for each area before we discuss how they apply to the particular project. I use this graphic organizer often. Thank you for your kind attention to my presentation. If you have any questions, my email address is there. I would be more than happy to send you copies of the graphic organizers or any other information about my STEM NGSS aligned projects.